We have a little more complicated mechanism here, but the analysis is exactly the same as before. So we have one bar, one member that looks like this, and another one that looks like an L. They're connected at point C, so we attach this point to here, and so we get something our mechanism looks like in the book. And then we either apply the load at um, A, D, or E. So those are all on the same vertical line. So what we have is we get right position vectors to all the points that are of interest. I used B as the origin, so this pivot point here. This is grounded at point F, and this is grounded at point B. And so we can write all of our position vectors with respect to B. And then our forces, I included them generally, and all of them, so we can set either whatever two we want to 0. So I solved the problem in general so that we can then get each part of the problem all at once. And so the first set of balance equations, so again we have 6 unknowns here. So we have 2 components here, 2 components here, and 2 components here. So we need 6 equations. So I did a force and moment balance on the entire structure. So on the entire structure we have our constraint forces A and B. We have B and F as our constraint forces, where there's pinned to ground, and then we have our applied load either at A, B, or E. And then in the second set of equations, so we're going to see all those forces need to sum to 0, and the moments created by them need to sum to 0. And in the second case, I just looked at this part, this member of the structure, and did force and moment balance on it. So we have just C, D, and E acting on it. So now C is not, if we break it apart, C is no longer an internal load for this member itself. So it gets exposed in that second set of 3 equations. So again, we have 6 equations, 6 unknowns, and again, it comes down to doing the algebra. And so I did the algebra. Well, actually I had the computer do the algebra, and I would advocate you also learn how to have the computer do your algebra for you too. It makes life a whole lot easier. So we have FB and FF. So these are the 2 reaction forces at the pivots where the structure is mechanism is grounded. And so we can see that the horizontal component, it doesn't really matter. It doesn't matter where we put the load. If at A, B, D, or E, we're going to get the same value here for each of these. So in that, it turns out to be 32. So 32 pounds. And then a negative in the other reaction at F. The horizontal component does matter. So if we have the force at D, we're going to get a larger horizontal component in the at B. And here, if we have the force at A or E, we're going to get the largest horizontal component at F. So we get, when it's at A, we get 10 here, and when it's at B, we get 24, and when it's at E, we get 10 again, okay? And so when it's down here, when it's at A, we get 38 pounds. When it's at D, we get 14 pounds, and when it's at E, we get 38 pounds again.